Hi everyone. So today we are here. As we said last time, now we are going to start solving non-exact differential equation. Okay. Um, we know we already know what is exact differential equation. Any exact differential equation, it is an equation that it is in this form. Okay. It's an equation in this form, written in this form, but the point is that when I take the derivative of m with respect to y, it will be or it will not be equal to derivative of n with respect to x. So in this case, we call this differential equation like non-exact differential equation. Suppose we have this one, m of x y, okay? It is a differential equation that can be written in this way: m of x y dx plus n of x y dy equal to 0. So it is exact when del m, okay, how can I say, partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So if it is true, we can call this is a differential, how can I say, it is an exact differential equation. But if this is not equal, we will say that this is a non-exact differential equation. So what we have to do in this case? In this case, we have to multiply by an element, okay? We have to multiply both m and n. We will multiply the whole expression by an expression that can reduce this equation into a exact differential equation. And this this expression that can reduce a non-exact differential equation to a exact differential equation, we call integration factor, okay, or integrating factor, if. It is integrating, okay, integrating factor. This is the expression that we use, or the function that we use to multiply the non-exact differential equation, to reduce it to a differential, to a exact differential equation. So then we can apply the method of the exact differential equation. Okay. Okay. Integrating factor. Yeah. Okay. This integrating factor may vary from situation to situation. This is what we are going to see. We are going to see first for case 1. In this case 1, it is for homogeneous differential equation. Okay, suppose we have a non-exact homogeneous differential equation. Okay, and when or how it happens. Okay, that's the point. See, non-exact differential equation, case 1. In case 1, suppose we have this is a differential equation and this is non-exact differential equation. We know what does it mean, non-exact differential equation. It means that differential of m with respect to y is not equal to differential of n with respect to x. So what is the next step to see? Okay, see if the function is homogeneous. So when m of that mxy and nxy has the same degree in all terms, then we call this as homogeneous function. And it is not and are not, okay, and are not exact, and this expression are not exact. Okay, so the most important thing is this function is this function or is this function homogeneous? Yes, it is homogeneous. Second step, is this equation non-exact? Yes, it is non-exact. So what we have to do, we have to find if, integrating factor. So what is integrating factor? It is the term that we use to multiply this, okay, we will multiply this non-exact differential equation for this integrating factor to reduce this non-exact differential equation to a exact differential equation. So when I have homogeneous function, what we have to do, we have to multiply by integrating factor. And for homogeneous function, okay, that are not exact differential equation, we will multiply this formula for integrating factor. Okay, so integrating factor for homogeneous function that are not exact differential equation is if equal to 1 upon mx plus ny. Okay, we know what is m and we know what is n. directly. Then what you have to do, after multiplying both terms of this equation by the integrating factor, you will reduce this equation into a exact differential equation. So after reducing this one, you'll get m1. This m1 is after you multiplying by integrating factor. Okay, m1, we will just solve for this because we will just have the right. Now that this is exact, we can apply the formula for exact differential equation, that is integration of m1 dx where y is a constant and n1 dy equal to c. Here we will exclude all the terms of x, and then we can solve. Okay, let us solve one exercise to have you across this method directly. Okay, let us take this expression here. Okay, let's solve it. Okay, as you can see here we have this expression. So the first step to do, okay, we are in case 1. The first step to do is, let us see whether this function is exact or not exact. Okay, now to check this one, we have to take this one, just compare. Okay, we'll compare. Okay, compare this expression here above with this one, m of xy dx plus, okay, plus n of xy dy equal to 0. So if you compare, you'll see that m is here and n is here. Okay, then here we have m is equal to x cubed plus 3x y squared. Okay, and n is equal to y cubed plus 3x squared y. Right? Okay, now let us see whether this function is or not exact. Just find derivative. Okay, just find derivative with m with respect to y, and here find derivative of n with respect to x. Just derive this and derive this one. It will be with respect to y, it will be 0, and here it will be 2y because 3x is constant, so it will be 6xy. Now here, if you derive with respect to x, this will be 0. With respect to x, it will be 6. Okay, 6. Let us see. Yeah, 6xy2. So it means that here this expression is directly. How can I say? This expression is if we just compare del m and del y, del m del y, and del n del x, they are equal directly. So we can say that this function is directly what it is. It is exact. So when this is exact, no problem is in. Okay, we cannot apply this theorem directly. If this is exact, we can just solve it directly. No problem in this. Okay, nice. Now let us pick up another equation. Okay, another differential equation, because for exact equation we have already solved. Okay, we know how to solve it, and this is easy. Okay, now let us solve for one case in which we can apply directly the concept of this case 1, when this is a homogeneous differential equation that is not exact directly. Okay, as I was saying, so this is an exact differential equation because this del m del y and del n del x are equal. Okay, in this case they are equal. So whenever they are equal, so yeah, what's the next step to do? Just integrate this expression and integrate this expression. Okay, and this will become something like this. Okay, integration of x cubed, okay, x cubed plus 3y squared x dx, okay, plus integration of y cubed plus 3x squared y, okay, and here dy equal to c. Now what's the next step? We know here we have to consider y constant. Okay, y is constant. Okay, and here we have to exclude. Okay, exclude all. Okay, exclude x terms in the equation. So this one will be easily, okay, y is constant, so here the integration will be directly integration of x cubed dx. It will be x to the power 4 by 4. Integration of this guy, 3 and y square are constant. So as 3 and y square are constant, it will be plus 3y square constant. Here it will be x square by 2. Okay, plus, and here this integration, we know that we will have to remove all the terms in x. So this term is in x, we have to remove. It will be only y cubed, integration of y cubed dy. So this will be y to the power 4 upon 4 equal to c. So easily you can write and find the solution for these differential equations. Okay, and we are done. Nice. Now let us jump for a different case, a case in which we can apply the concept of the case number 1, that is an homogeneous differential equation that is not exact. Okay, so suppose we have here now, okay, x square y dx minus x cubed plus y cubed, okay, plus y cubed, and dy equal to 0. So we have to do the same thing. Okay, now check, just compare first. Okay, mxy dx plus, okay, nxy dy equal to 0. Just compare. This will be your m and this will be your n. So m will be equal to x squared y. Okay, and what is your n? N will be minus x cubed plus y cubed. Okay, now that you have found your n and y, so let us see whether this function is or not exact. Del m with respect to y, you just derive this one with respect to y, it will be x squared, and del n with respect to x, just derive this expression with respect to x, this will be minus 3x squared, because y is constant. Now see, they are not equal. So here we can see that here del m del y is different of del n del x. So it means that it is not, okay, it is not exact. Okay, the equation is not exact. So if the equation is not exact, now check, is this function, or is this equation, is this function here and here homogeneous? Are they homogeneous? Just check if they are homogeneous. So here you have x to the power 2 and x to the power 1. 2 plus 1, it will be 3. Okay, so here the degree is 3. Nice. Now check here the degree. What will be the degree here? X to the power 3 and x to the power 3. So all the terms of this equation have the same degree, and the degree is 3. It means that this function is homogeneous. Okay, these polynomials are homogeneous directly. So if this is homogeneous, now we can apply. Okay, now we can see, just check here, when the function is homogeneous, we have to multiply the whole equation by a very known terms, that is IF, integrating factor, to make it reducible for to reduce it in a exact differential equation. So let us find what is our IF, integrating factor. Okay, in this case we find what is integrating factor. What is our integrating factor? So that by multiplying the whole expression by integrating factor, we will have our not exact differential equation reduced to an exact differential equation. Okay, and for homogeneous function, we use the integrating factor. Okay, IF for homogeneous function is 1 upon mx plus n. Okay, it's n time y. Okay, now let us find what will be our IF. So here, what you have to do, just pick up your m. What is your m? M is this one, x squared times y. So it will be x squared y, okay, time x plus, what is your n? N is minus x cubed plus y cubed. So this will be directly, we can just substitute here. This will be minus, okay, minus x cubed plus y cubed times y. Okay, times y. Then here you have just to find what is your IF. After find your IF, okay, this will be what? This will be y cube, x cube y minus x cube y, and here also minus y to the power 4. Okay, so if you see x cube y will going to be cancelled out, so it will be 1, okay, minus 1 upon y to the power 4. This is our integrating factor. What's the next step? We will have to multiply, okay, all this expression. We will multiply the whole function with the integrating factor. So what we are going to have, IF time m of xy dx plus n of xy dy equal to 0. Okay, this is what we are going to have. So multiplying this will be minus 1 by minus 1 divided minus 1 upon y cube, or y to the power 4. Go there. This will be x squared y, okay, time minus 1 y cube, okay, plus or minus, it's upon them, it's minus, then multiply also minus 1 y cube, and here x cube plus y cube dy equal to 0. Okay, just multiplying this, it will be easier. Now what's going to be here, you got x squared, okay, by negative here x squared by y cube, and here plus minus and minus plus, this with this and this with this. So this will be directly x cube y to the power 3 at the power 4, then plus 1 upon y, and here dy, here dx dy equal to 0. Okay, now you have a different one. Now you are going to call this m1. Okay, this is m1. M1 is minus x squared upon y cube, and n1, it will be this expression hold here, x cube y to the power 4 plus 1 upon y. Is that okay? Now that you multiply by the integrating factor, this expression is reduced to a exact differential equation. If you find the derivative with this, and derivative with this, if you find del m1, okay, del m1 with respect to y, okay, this will be the same as del n1 with respect to x here. Okay, just find the derivative with this with respect to y. Okay, what will it be? It will be directly, everyone knows, just so it will be just x is constant, take out, so this will be positive x squared, positive. So here will be this guy, derivative of this y cube, this will be 3y squared all upon this 1 to the power 2, so y to the power 6. So just do some simplification. Okay, here what you get this 3, and this one will be cancelled out with this, so this will be y to the power 4, and here it will be 3x squared. Okay, this will be the expression that you are going to get for del m1 del y, and the same expression you are going to get here. Okay, it will be the same, because if I derive with respect to x, this one will be 0, and this one will be 3x squared, and here y to the power 4. See, the expression will be the same. Okay, yeah, so after you multiplying by the integrating factor, you can surely write del m1 and del y is equal to del n1 and del x. You can just directly put it together, because this integrating factor has this function of making this differential equation that is not exact, that was not exact, to a exact differential equation. Okay, now that we know that this del m1 del y is equal to del n1 del x, okay, so it is equal, so we can apply now the exact differential equation formula. And you remember what is this? Okay, I will remember. I will make you remember. Don't worry, it's fine. So this one is directly, now that we know, so we have just to apply integration. See, just apply integration for this expression here. Okay, just integrate this part and this part. Now this integration you have to consider y as constant, and this integration you have to consider x excluded. Okay, all the terms that have x must be excluded. So this will be minus x squared. See, integration of minus x squared y cube dx plus second integration is integration of x cube y to the power 4 plus 1 upon y, and this is del y equal to c. Okay, this is what we are going to do. So here we know that y is constant. Okay, and here x excluded. You have just to exclude all the terms of x. Okay, yeah, like this one we have to exclude, and here y is constant, take them out. This will be minus 1 upon y cube, and here x squared dx, y constant, and plus integration of 1 upon y, it's like dy upon y equal to c. It's okay. Now this integration is very easy, minus 1 upon y cube, and here it will be x cubed by 3 plus, and here you got again ln of y, okay, plus c. So this integration is the general solution. Oh, this expression is the general solution for this exercise right here. Okay, just do remember, okay, in when the function is homogeneous. Okay, if the function is homogeneous and it is not a exact differential equation, what you have to do, just find the integration factor. In the integration factor for homogeneous function is this one. Just have it in your mind. This is the integration factor for homogeneous function. Okay, so first check whether this is exact or not exact. If it is not exact, now check whether this function is homogeneous or not, and we checked and we saw that this is homogeneous. So if this is homogeneous, just find IF, integrating factor, that is 1 upon mx plus ny. And after finding this, what you have to do, just multiply this IF to the general expression, to the whole equation. Multiply here, as you can see, to the whole equation. So the remaining expression that you are going to have, the remaining equation that you are going to have, now it is your equation reduced to an exact differential equation, and this reduced to an exact differential equation will be solved by the exact differential equation method. Okay, just like this. And here you know m1, this is derivative of m with respect to y, this is derivative of m with respect to x. These are equal, these are exact. So what we have to do, apply integration here and apply integration here. This integration here will be considering y as constant, and this integration here will be considering x, all the terms in x excluded. Okay, as you can see here. Okay, excluded, just solve, and this will be this, and this is constant, so it's done. Thank you very much. So you have some other exercise that I preserved here for you to solve. Okay, just in case you feel like you want to solve any exercise anymore. So yeah, just for you to solve this one, y power 4 dx plus 4x cubed and y cubed dy equal to 0. You can try on this. Okay, you can try on this, or you can try on this also. Okay, there are infinite exercise that you can try on. Okay, dx minus x squared minus 3xy and dy equal to 0. Or you can try also, there's one exercise, let me see here. This is x squared y dx, okay, minus x cubed plus xy, okay, xy square here dy equal to 0. Okay, you can try this exercise home, and anything, just let me know. Thank you very much. See you for the next stage. Okay, this is for case 1 when this is homogeneous function. Okay.